Twitter analytics people think the former is sophisticated, while the latter is for bumbling chuds. Any bumbling chuds in chat? I don't know what chuds means, it just sounds provocative. Here goes an analytics vibes thread without any actual numbers. This is from Kanzi. Kanzi in chat right now. All these XYZ over expected. SIPO. Rio. We've made some over expected notebooks here. Let's see. Here's one that we made that was fun. This was for Blitz beer. So this is a data blitz. So in a data blitz, I have 30 minutes to do the data science and create a PowerPoint and then ultimately present to everyone in chat, and then they grade me on how well I did. So, this was the beer data set, and I didn't get to all of it, but what we created was this over expected metric called rating over PBR. If you're familiar with replacement level players, I assumed that the replacement level beer was Pabst. So I wanted to know what my predicted rating was over the average rating of PBR. That created my advanced beer analytics metric, rating over PBR. And I believe one of these graphs is probably, oh yes, this was breweries that are better than PBR. Oh, that's right. Okay, it was 2 models. Okay, so I trained one model on just all breweries. I trained another model on just PBR labeled beers. So there's like not just PBR, but there's actually like 3 or 4 different PBR flavors? I don't know what you call them. Styles? So I trained a model just on PBR beer. So basically, if you put the same ingredients or you had the same rating on just, you know, a model that's well trained across all breweries versus a model that's specifically trained on PBR, you throw all your features in and how good is the PBR, even with the best, you know, ratings, subcategorical ratings. These beers outperformed PBR, these breweries. And there's some of these breweries that are like, yeah, that makes sense. Here are the breweries that were apparently worse than PBR, which includes Athens, Ohio's Pride, Jewel, Jackie O's, which is unfortunate because Jackie O does make really good beer. Also, lol, the breweries in here. So yeah, that was a metric. But this kind of goes back to the idea of what we're talking about, right? Like, this is what Kanzi is saying. All of these over-expected metrics are just methodologically wrong. How can we attribute an entire residual to a single player? Reading residuals is like astrology for PFF nerds. This one's very spicy. Creating rush yards over expected involves creating an intentionally inferior player-agnostic expected rush model that assigning the entire difference between actual run yards and expected run yards to the ball carrier. Yep, let's just ignore all epistemic uncertainty in models. Feels like in an effort to do advanced analytics, but this is strike through. See, this is how you know Kanzi doesn't actually write in Markdown that often. You're just striking through advanced analytics, man! Feels like in an effort to do advanced analytics, football analytics community has made this XYZ over-expected a blueprint for building a new metric without actually thinking about what's going on. Yes. Us mindless, just the football analytics community. Okay. This is probably just any sports analytics community person, because it's so simple. The idea that actual minus expected is attributable to anything is the closer suggestion that what you're predicting not only has accuracy, but has like signal above whatever is being output as like a raw value, right? Like, I did this in my notebook, and you know, this is exactly what Kanzi's talking about. when I was doing what the fuck was it? My work, calculating distance from other players. So I do an extremely simple use case for distance, right? So I have all the Euclidean distances for all the linemen, and basically, like in the aggregate, it looks fine. But I end up creating an over-expected metric because for all the players who end up having 0 pressures allowed, like, is that 0 pressures allowed because, like, there wasn't really much pressure in their face? They weren't really blocking against pressure? Or is there a way to show that 0 pressures allowed actually means, like, you protected against a player more than you should have, right? And we see here, like, over the course of a game, in this particular week, Brian O'Neill ends up not allowing 5 pressures over expected, right? So this is 5 pressures under expected, I suppose. So this is like straight up what Kanzi is saying is bullshit, right? Kanzi is saying, like, well, you can't just make a model and then, like, subtract that from actual and say, like, this entire value is attributed to Brian O'Neill. Because similar to a completion percentage over expected, and we've done this on this stream as well, I tried to separate out the responsibility, or really the weight of a receiver in a particular play versus a quarterback on a particular play, right? Anyway, let's keep going. Is rush yards over expected any better than yards per catch? Yards per catch? Twitter analytics people think the former is sophisticated, but the latter is for bumbling chuds. Any bumbling chuds in chat? Also, shrewds in other modeling areas already know how silly it is to read too much into residuals. Rush yards over expected, or whatever it is, literally, or whatever is literally just trying to predict the direction of polling error. Some of y'all don't like Nate Simmer, but he's correct here. Don't try to predict the direction of polling error. I don't know what chuds means, it just sounds provocative. In most extreme cases of attributing a whole residual to a factor not in the model, you get some funny stuff like a ref being worth 12 points in an NBA game. Not great. Obviously, many other factors, especially luck, given the tiny sample. Right, so, like, calls over or under expected. Yeah, attributing everything to, like, attributing all the... And this is really particular in games, in sports that are N by N on a field, right? Soccer, basketball, hockey, football. Even in baseball, when you have fielding metrics, for example, you'll see, like, on Baseball Savant, something like outs above average. Like, what is the average, right? There are several models before you get to that one number, but you have to account for, like, what's the probability a fielder can get to it? Does the fielder get to it first? Because not all, like, outs above average are caught in the air. They're ground balls too, right? There's a lot to be considered before you even get to the end, which is outs above average, right? Whereas in a lot of different, not just big data bowl metrics, but in general, like any play-by-play or event-based metric, not just in the NFL, but in any statistic that's out there publicly, you do end up trying to strip down a lot of what is of the nuance in favor of one comprehensive model. But really, when you throw everything to some sort of model that's supposed to comprehend what's happening on a given play or whatever the sampling level is, you do end up getting, like, as Kanzi put it succinctly, a direction of polling error. In what direction, and this is like if you're using point estimate stuff, so like the stuff we tend to see most frequently out in the public, if a model is ultimately just trying to predict a mean, or a mean given the conditions of the features, then we are ending up, like, saying the direction of the projection is headed in this positive or negative direction, right? And it's not necessarily any one specific number that's supposed to evaluate this, but rather like a spectrum of numbers. Rather, a distribution of numbers is supposed to is supposed to lead us to believe, like, all right, well, how much will this end up being positive yardage if it's rush yards over expected? How much is this supposed to be positive events that are occurring if it's baseball event over expected? How much of this is supposed to be goals attributed to a player if it's XG goals over expected or something? So for the most part, when you're creating over expected models, you end up having a relatively complex or very large model that has to take into account a multitude of, as people are saying in chat, mixed factors are really just many interactions, right? And when you're saying that one thing is happening and it's due to this gigantic interaction of things, you end up, it's not disingenuous because theoretically that's where your methods have led you, but for those who are trying to make a mountain out of a molehill, for instance, like rush yards over expected, completely attributed to a running back, that is maybe disingenuous representation of what rush yards over expected should mean. Because really, a rush yards over expected model is supposed to be in the context of the play, right? Not in the context of the player, right? And Kanzi talked about this maybe one big data bowl ago, two big data bowls ago when me and Ethan were doing it. And he alluded to this in my Discord, which was like, we're trying to attribute a player with like ball pass protection. Whereas it's not really a player, it's really remodeling the system of the play. And if we're trying to attribute a player, then we need to do more at the player level, right? Which is true. Okay, so I'm picking some bad XYZ over expected metrics here, but what about SIPO? So it seems to at least somewhat useful and decent year-to-year correlation. I don't think that's necessarily a good way to evaluate these metrics, but we could save that for another. Even in SIPO's case, you're implying that player-agnostic expected completed pass model parameterizes everything except for the quarterback. That's not true. So implying that a quarterback has full control over residual is nonsensical, right? So again, when I tried to create wide receiver responsibility or wide receiver weight and quarterback weight split from SIPO, because really, like, my question about completed pass over expected, I was like, well, is that because it was a hard pass to make or because it was an incredible catch? I set off on a journey and I found out that it's actually pretty near impossible. And Ben in chat, he knows. I bashed my head on that project for like several months and got nowhere. And I thought I had a good answer. And then I looked at year-to-year correlation, and it was literally like a circle. It was a circle, and it wasn't even a circle with a straight line across. It was a circle with a regression line going up. It was so fucking twisted. Which means that it is relatively hard, if not impossible, with the data given in the public right now, to separate out the responsibility of the receiver versus the accuracy of the throw, right? Like, did a quarterback make a great throw or did a wide receiver make a great catch? SIPO actually doesn't give us information about either. We can assume that the quarterback had made a great throw if it was a low probability of completion. We could assume that the wide receiver had to make a great catch simply because it was a low probability of a catch. But we can't necessarily say one of them had more weight or responsibility than the other on a particular pass, right? However, when we look at SIPO, it is a quarterback metric. Receiving SIPO, we tend not to see as publicly because people don't consider it, at least in the current state of analytics in the NFL, people don't consider a wide receiver statistic. Even though, as Kanzi's saying in his thread, like, if you consider one metric better than another, like, what's the reasoning, right? Like, if you have one over the other, why? Like, is it just because you threw this into an XG boost model and this one was like, you could do it in Excel? Like, is that the reason? Similarly, that's the thought of like, why are we only using particular statistics to describe particular players? I also think is a valid reason, right? So my thought here is, yes, some of these metrics might be overstated in the public eye, but for the most part, I think it's less about like people promoting bad statistics, and I think it's more about people using statistics in narrow ways. I think a lot of the time we get caught up in saying like you're doing something bad or you're doing something good. But rather it's like we're all trying to advance the field, and it's rather haphazardly, right? Like we believe certain things should correlate with ability. We believe certain things should describe specific players, but really like one metric can describe many different players, right? And we end up getting to an issue of like double or triple counting one stat for many players. But we do that already, like with yards or with sacks or with interceptions. We're double or triple counting things, right? The league even does it at the official level with like half sacks, right? Like you can only get one player gets sacked on a play, and yet we're giving out credit for half sacks for people, right? Like what is like we're already doing it in an official capacity. If we're already double counting stats, triple counting stats, why narrowly use statistics in ways that only reflect one particular player, one particular situation, right? I don't want to believe that Kanzi is actually arguing against making good comprehensive models that explain certain situations, and it's probably far from that. Kanzi is saying like let's be smart about how we apply that statistic outward. But someone out there, oh, it's Bomani Jones. Didn't Bomani Jones say something like, if people in analytics are saying that we don't understand, like the layperson, if we don't understand analytics, isn't that more of a problem about the messaging or communication of analytics than it is about us understanding anything? And a lot of the time, I do think that we throw stuff out there, and we, as a community of analytics, sports analytics people in the public, we do throw things out there, and we expect people to get it because we believe that it's like a succinct, easy thing to understand. But we don't go an extra mile on a lot of these things where we're really trying to get people to understand, like, well, these are the factors that go into it, and this is the reason why it's an important statistic. And maybe the marketing of it is not good right now, but help us figure out a way to explain it. Help us figure out a way to market it. They don't even want that. They want us to go further. There is no help here. It's analytics needs to give us the playbook, which includes how to talk about it, which includes how to say, like, how to use this in conversations, how to move a conversation forward, how to make a decision happen, right? Like, we need to know everything about it, not just what goes into it, but how to use it in a sentence, right? How do we make other people understand what it is? Just like when someone says, like, 6-4-3 double play, like, we also need to say, yeah, defensive run save, blah, blah, blah. Those two things should click equally if we as an analytics community are doing the communication side of analytics as good as we're doing the modeling and statistics side of analytics. I don't think Kanzi's picking a fight with people who are making over-expected metrics. I think over-expected metrics are an example, and expected metrics in general are an example of the state of sports analytics that we're living in, which is trying to represent as much as possible and predict one thing out of the entire universe of things that are happening. And we do end up saying that the thing that we're leaving out of the model, the thing that we're predicting on, the thing that we're subtracting, using subtraction method against, we tend to say, like, our model takes into account everything. Therefore, the residual, the difference, the over-expected is actually representative of literally that one thing. But really, it's representative of everything that goes on into a play or everything that goes on in your models, plus here's the event that tracks whatever we're looking at, right? It's not really like modeling is bad and you should be angry because you model. It should be what Kanzi is really trying to say, in my interpretation, I don't know if this is true, Kanzi, you could correct me if I'm wrong. What I think he's trying to say is, like, one of two things. Either, like, let's not push forward a metric that we think is omnibus to some sort of skill or trait if it isn't, right? Or if it is, attribute it to as many players as it actually accounts for, right? But omnibus statistics, generally, it's hard to represent one player in an omnibus statistic. On the other side, if we are able to communicate what is actually going on in our models, then maybe we avoid all of this altogether. If we are able to actually say, this is what this model represents, and this is how we should interpret it, then maybe that's actually the more important thing, right? Like, communication goes a really long way in analytics because you won't have people questioning whether or not we, Larry Fitzgerald, did you take into account the speed of the wind or the direction of the rain? Like, people wouldn't question us with that kind of stuff if, one, like, that was a clear understanding that that is data and that's going into models. But two, if there was just a general idea of what an expected metric's trying to do, right? And I think that's what the fear is. Like, the general reaction from non-analytics people are like, you're trying to say that my quarterback makes more passes than he should, or makes less passes than he should. Well, that's one thing, but what about the receiving core, right? Or you're trying to say my running back doesn't run as far as he should, or runs further than he should. Yeah, but what about the offensive lineman or the strength of schedule? What about the secondary defense that plays a little more shallow than they do deep that you end up playing against in random samples? And this is, again, going back to Kanzi's point about small sample, right? So I think there's a lot of points to be taken from here. And the biggest one, in my opinion, which I think is a minority opinion about what this is all trying to say, is like, we need to be able to like properly communicate what a metric is actually trying to say, right? And obviously there are places out there where you could find that information. But I think all of us, whether you're hobbyists, whether you're a data scientist in real life, or whether you're in sports analytics, like it is upon you to make sure that the information you're putting out there is representative of ultimately the universe that you're trying to describe. At the end of the day, it's the scientific method. We are witnessing phenomenon, and we're trying to attribute objective ways to measure that phenomenon. And if our objective measure is a bad ruler, if our objective measure is a yardstick that isn't quite a yard, or a little more than a yard, then the questions do come in, and it's hard to defend when you completely entrust in your yardstick, right? You should be comfortable that someone's out there challenging the idea that maybe our messaging or maybe the attribution of a particular statistic is just not correct in this moment, right?
What's a pirate's favorite programming language? Arr, 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 arr.